Hi everyone, my name is Zhang. I'm the PhD student from the Rutgers Accounting Information System. So today I'm glad to introduce the paper we are working on, the visual audit approach, integrated audit approach. So for this paper, I work with another PhD student from our department, Erica Lee, and the Professor Chi Liu from University of Rhode Island. So this is the agenda for today's presentation. So for this paper, the main contribution is that we create a framework which integrate visual analytics with the traditional audit approach and audit data analytics. So at the beginning, I will briefly introduce what is visual analytics. Then I will introduce our model, the visual audit model. Then I will perform a short demonstration talking about how we apply this model to hospital data, to a hospital audit. So first, let me introduce what is visual analytics. As you may know, so data visualization is a very popular way to just represent the data using the graph. So visual analytics, also we call it visual data mining. It extends data visualization by integrating four different line of methodologies. First one is the data analytics or data mining or machine learning methodologies. The second one is the so-called human factor, or to put it simple, it's just the interactive actions or the interactive techniques. The third one is data management methodology. The last one is the knowledge generation methodologies. So this is visual analytics. So for our paper, we take the first step, aiming to integrate this visual analytics with the audit data analytics. And we build our model based on multiple lines of different research. So such as the data visualization process model design research, the semiology of graphical sample design research, or we call it the grammar of graph research. The third one is taxonomy design of visualization tasks and goals. Also, we borrow some taxonomy developed, proposed by some data management research. Also, we follow some human perception classic series, some human reasoning and sense making series, and also last but not least, we introduce the very popular classic theory, the cognitive fit theory, into our model. And this is our model. So I will, in the next couple slides, I will decompose our model and introduce them, or introduce our model in more detail. So basically for our model, we create 5 different spaces or to represent five different process, either a system operation process or the human cognition process. So the 5 different spaces are illustrated in this graph by those circles with dash lines, and those space, they are the goal and intention space, the interactive action space, the visualization system space, the knowledge space, and a very small space called perception space. In each space, we also create different components following the previous literatures, and those components are categorized into 2 different broad types. The first one is the concepts, represented in this graph as those rounded rectangles. So concepts are those different concepts held by auditors in part of their cognitions. Another type of the components, it's the so-called container, are represented by those regular rectangles. So containers contain some physical system data or some documents or some graphs or tables, etc. and etc. So and we connect those different spaces using those the information flow represented by different arrows, or we connect those different spaces using the so-called sense-making human action loops represented by those curved arrows. So this is our the whole picture of our framework. Then I would like to decompose it and I will introduce the space one by one. So first is the goal and intention space. In the paper, we argue that for conducting a visual audit, the whole process should be triggered, should be guided by the goal and intention developed by the auditors. And a goal is defined as a so-called ear-defined tasks, or in other words, it's a general, we call it a general task. So based on the previous literatures, for visualization, there are three broad goals. First one is called exploratory data analysis. Second one is called confirmatory data analysis. The last one is called presentation. So for exploratory data analysis, we call it EDA, so which is the bottom-up data-driven approach. The goal of EDA in visual audit is not to draw conclusions on predefined questions, but to inspire some idea and a hypothesis. So in other words, the goal of EDA is to generate some audit-related hypothesis. So once you formulate some hypothesis, uh, after EDA, so auditor could perform the so-called CDA to confirm, to test or reject those hypotheses. So CDA is the confirmatory data analysis. It's a top-down approach. And the last goal for in this space is a presentation. So the goal of presentation is to accurately, efficiently, and effectively communicate information from the graph, from the visual to the auditors. It is the goal not only for visual audit, but for all the data visualization process. So in order to accomplish that, so auditor need to take some human perception theory, or need to take their perceptual limitations, their perceptual abilities into considerations. So I will talk about that later in this presentation. So this is the goal. Once you have the goal, based on the goal, you have to form some intention to facilitate the subsequent actions. So in this space, we define two different intentions. One is so-called intention to perform the high-level visual task. Another one is the intention to perform the so-called low-level visual task. So based on the previous literatures, high-level tasks are those tasks related to your knowledge domain, your problem domain. So in visual audit, we define the intention to perform high-level tasks as audit objective. So for auditors, what you want to accomplish using visual audit, what is the real problem you are facing throughout different stages in the audit process. And those objectives, it's not static, they are dynamic. They are adjusted to the feedback from different visual results. And for example, auditor could develop a very general, a so-called abstract objective at the beginning, then based on feedback, they drill down into a more detailed and concrete audit objective. The low-level tasks are those so-called basic visualization tasks. They are independent from the problem domain. They are independent from your knowledge domain. So we define the second intention as the intention to perform the low-level tasks, and we name those intentions as needs for visualization. So they are or the intention to perform some basic tasks like finding clusters, finding outliers. I want to rank something. I want to compare something. I want to identify the distribution of the data. I want to conduct temporal analysis, geospatial analysis using map. I want to conduct composition analysis. I want to find some relationship among different entities. So they are all the basic general visual tasks. So the reason why we name it as needs for visualization instead of just using like a basic task, because we believe auditor for different basic tasks, sometimes you don't need visualization to solve your problem, because based on the previous literature suggested, visualization is good at detecting differences, and they emphasize on the so-called relative judgment instead of the absolute judgment. So before for auditor, when they are developing their goals and intentions before physically conducting visual audit, they need to find the needs for using visualization at the first place. So that's why we name it as needs for visualizations. And also those needs should be formed and developed based on the developed audit objectives. So that's the first space. After auditor have those goals and intentions, they start interacting with the system. So we create a system space called visualization system space. So in the space, we uh, categorize three containers as data, varset, and the visual. So data is just the data of interest, the data you connect to your data set, the data you want to use to find something, to perform the audit, the data that meets your audit objectives. That's the data. Then from the data, you create a var set. So var set stands for variable set, which contains a list of different variables that you are going to use to map to the graph, to map to different graphical entities. So that is a var set. So for those variables in the var set, they could be just the original variable from the data. They could be some regenerated variable from data based on some simple formula and functions. So they could be some ratio, recalculated ratio. They could be some bins, ranks, groups, stats, or some specified relationships like hierarchies, relations, flow, or the aggregated descriptive statistics like average, like median, standard deviation. And also those variables could be derived from some complex data mining algorithm. They could be like cluster number. They could be principal components, variable number. They could be some forecast predicted using some regression algorithm. So that's the var set. So in the var set, you have variables, either original or recalculated. With for each variable, you have a long list of records and instances, and you map those variables to the visual, the graph, to different graphical entities in your final visual results. And we categorize those graphical entities into three types. The graphical objects, which are different geometric shapes like line, air, like point line, area, volume, surface, etc. And visual variable, it's their variations like position, shape, size, brightness, color, orientation, texture, and motion. And also you need to add some guides into your visual. So the guides are the supplementary information which will help auditors to gain some absolute judgment. So those guides could be access, ticks, marks, reference sign, label, annotation, legend, and key. So this is the system space. The way auditor interact with the system is through the interactive action, different interactive actions. So we categorize those actions in the interactive action space. So for each containers, we classify different actions. So for data, we have actions for data preparations. We have connect, clean, and shape. For var set, we have action for var set creations. We have import, search, filter, calculate, abstract, elaborate, data mining. For visualization operation, we have action for visualization operations. We have navigate, select, recalculate, encode, and link. So reconfiguration, sorry. So encode here is just mapping. So how the process of mapping, how you map your variables and instances in the var set to the graph. The link here refers to linking graph and graph, or graph with and tables, or graph and the verbal explanation into a consolidated one single representation format, such as a dashboard. So that is the linking. So the ultimate goal for the visual audit process is to obtain some knowledge from the data from your client. So we create a knowledge space. So in the knowledge space, we have different concepts and a container which ultimately will reach a solid knowledge for the auditors. So we categorize three different concepts. First one is finding. So finding is just a pure visual pattern independent from a problem domain. Like it's like you find a spike, you find a dump. So that's a pure visual pattern. So, but for visual audit, auditor need to interpret those findings. You must interpret those findings based on their knowledge. And the interpreted finding is defined as insight. So also we call it knowledge-based insight. All right. So the new insight may lead to another round of EDA process, or those insights could be used to develop a new hypothesis, and that hypothesis will lead to a new CDA process. So hypothesis is defined as an educated guess, and those hypotheses developed in visual audit, auditor could confirm those hypotheses through the visual analytics system, or they could confirm those hypotheses through other traditional audit approach, like a testing of detail, like inquiry, based on their needs. So that's a hypothesis. And the important container or the important document auditor could obtain through visual audit is audit evidence here. So in visual audit, we define audit evidence as a properly documented collection of insights. So what is proper documentation means here? We argue that a graphic representation emphasizes more on relative judgment rather than absolute judgment. So we argue that if you use pure graph or images as audit evidence may lead to potential misinterpretation and distortion. So in order to obtain a reliable audit evidence in visual audit, we have to link those audit evidence with other text-based source financial information by adding, for example, guides to the graph, by attaching table or verbal explanation to the graph. Because based on the previous literatures, they suggested that using dashboard or using hyperlink to link verbal documents with graph will help mitigate misinterpretation and distorted graph. So that's why that's how we define the audit evidence in visual audit. And the last one is the perception space. Based on the previous literatures, actually perception linked the human cognitions with the visual results. And the perception is just the process by which we interpret our environment around us. And the amount of knowledge gained from visual audit is limited by auditors' perceptual abilities, which is also studied in the cognitive field theory paper. So in order to have a superior test performance for using visualization, you have to find a fit between perception, which is one of the user characteristics, and the visual, the graph, the representation format. And also we argue that auditors also need to find a correspondence and a consistency between the task, which is defined as needs for visualization, and the visual. So they also need to find a fit between visual and needs for visualization in order to have a superior test performance for using visual audits to obtain knowledge and audit evidence. So, all right, so this is our framework. So this is the first part of our paper. And uh, uh, after we create a framework, we try to apply this framework to a real audit case. And we applied, actually, eventually we applied this framework to a hospital data. So we have conducted 6 different visual audits using that data. So due to time limitation of my presentation, I would like to briefly introduce 2 of them. So one is for revenue analysis, another one is for internal control test. So for the data, we collect the data from 45 hospitals, and we select one of the hospital as our target because according to a very simple clustering analysis, we find one hospital, car 11, it falls into a cluster which reported the highest bad debt proportion over the total transaction value. So we thought it might be an interesting target. So we select the client 11 as our target. We use the transaction recorded from 2014 to 2016. We used the account ID as our primary key. And in total, we have over 6 million transactions recorded for client 11. So let me just introduce how we apply our model to the hospital audit. So first, we start with the EDA goal. So we have no idea about data, so we just want to explore the data. We come up with a very general audit objective. We just want to understand the monthly revenue pattern of this data. So revenue here refers to the so-called net revenue. It's the revenue net of different deductions, such as contractual deductions, such as charity deductions, such as bad debt deductions, and administrative adjustment, those deductions. So this is the first graph we generate. It's a line chart because the needs is temporal analysis, and we believe line chart is suitable here. Um, we got insight here. So we find that huge revenue increases reported in March 2015. So this is the first insight we got by this first graph. So based on this insight, we modify our audit objective and we jump into another round of EDA process. So right now the audit objective is to find some possible reasons for those monthly revenue pattern. So the way we did is we drill down from the company level aggregated revenue into the accounts level, more detailed aggregated revenue. And we modified our var sets. Right now we have accounts ID as our variables for mapping. We have also calculate a regenerated variable called change of revenue, which is calculate difference between the revenue reported in the previous months and the revenue reported in the current month. So the difference between the reported revenue in 2 consecutive months. And for the visual variable, we use color to represent the revenue value. We use brightness to represent the difference. Therefore, we could magnify those exceptional accounts which reported exceptional revenue change in 2 consecutive months. And we did have another insight. We find some accounts reported exceptional revenue increase and decrease in 2 consecutive months, such as those lines demonstrated in the graph. So this is the second insight. So once we got the second insight, we develop a hypothesis. We assume that there might be some suspicious reversal transactions for some accounts occurred in 2 consecutive months. So the second insight lead us to a new CDA process, the confirmatory data analysis, with our hypothesis. We want to find if there are some reversal transactions. And we modify our var set law. Now we focus on the revenue recorded in March 2015 and April 15. And also we focus on those accounts which reported exceptional revenue change in 2 consecutive months. And we did find some accounts recorded huge amount of reversal revenue transaction between March 2015 and April 2015. Seems like they are borrowing revenue from April to March, but we do not know why. So in a real audit, auditor could use this insight to develop a more specific hypothesis, right? And they could confirm or reject those hypotheses through other audit approach, like inquiring or other audit data analytics methodologies. So, and if they confirm their hypothesis and they believe this is material and this will affect their opinion in the audit report, they could link this graph with other text-based source of financial information and document them as audit evidence, which is going to support their opinion. So this is the revenue analysis we have done. Another one is called we have done is the internal control test. So for this visual audit, we start with a hypothesis, right? Not like the revenue one. So for this one, we start with a hypothesis. We begin with the CDA process. So basically, we want to compare if the recorded total charge in the table equals the recalculated total transaction we calculated based on the sum of different transaction value. All right, including revenue, including bad debt transaction, contractual debt transaction, charity transaction, payment transaction. Theoretically, those two values should equal. The total charge should match the calculated total transaction. So any value difference may indicate positive internal control deficiency or some violation of auditor assertions. So we come up with this hypothesis, all right? We just directly jump into a CDA process and we want to test if recorded total charge match the recalculated total transaction. And we use a scatter plot, all right? And we did find an outlier here. So it's one account. The total charge recorded in the data is 1.3 million. The total transaction calculated by the system is 11.3 million. So for all the other accounts, so 99.9% of them, those value they equal. But for this one, we have a 10 million difference between the total charge and total transaction value, recalculate total transaction value. If we take a closer look at those two numbers, you will find that maybe someone, I don't know, they mistakenly, when they record the data, they mistakenly put one more one in the front, or they just mistakenly miss one, the necessary one in the front. So this is the insight. So based on this insight, again, auditor could develop a more specific hypothesis like what I have just said, and they could confirm or reject those hypotheses through other more physical auditor methodology approach procedures, sorry, like inquiring. They could inquire those employee who take charge of the data recording, right? So if the hypothesis got confirmed and they believe this is material regarding internal control, they could use this graph with those supplementary information, those guides, all right, get from our source financial information and use this graph as audit evidence, which is going to support their opinion in the final audit report. All right, so that's it for our paper.